Okay, well, probably heard this many a times before that last year's class, or even prior classes, could probably say, well, that's not really what it means. I don't have a whole lot for you today, so then all of a sudden it's 9:10 and we're still discussing things. But one of the aspects I want to talk about first is on page 314. Okay, and what that means is stereoisomerism, you see on page 314. You can look at it similar to how you learned that last year, and we'll put that in the context here, Gesundheit. And that would be, okay, if we saw this and then this, and we'll go. Okay. From last year, do you remember seeing something like that? Might not be very dark, but hopefully we get the idea. So what might be the first thing that we want you, well, maybe about the third thing. First would be your parent chain. Second would be what type of organic family it is, which is what? It's an alkene. Then the third thing that we would want you to recognize possibly is what, if you remember? Exactly. So you got a 50-50 chance. You say cis? That's correct. Mm-hmm. So you suppose if there's a cis compound, there's a brother compound too? Probably not. See, I was telling another staff member, I gotta have a little applause light up here or something like that. Saying that. I said, do you hear what I said about a cis compound? Oh, I said, you suppose if there's such a thing as a cis compound, there's a brother compound too? See, see the applause light just went on. Oh, and maybe it didn't say applause. Maybe it said, is it pity, clap? Is that what you would call that? No, we'll go with that. Okay, so those are what we want you to recognize. So it's really nothing that is totally brand new. We're just applying it in a different fashion that you see on page 314. Okay, and what you see there is what type of structures. It says cis and trans stereoisomerism in, when we say cycloalkanes, it can be any type of ring structure, whether it's a 3-carbon compound, a 4-carbon, 5, 6, okay? We don't spend a whole lot of time on there because, and this came up in discussion last night, if we cover some of the basics that when you see this again, then you're familiar with it. You're not, you're not having to spend so much time on something like that. And hopefully we can view that as a great benefit for you, for those of you who have taken this class and have to take the organic class in college. Okay. So we'll go ahead and do something. Is this marker about had it? Because I'm standing about 10 inches away and it looks fine to me. And then in your cases where we're at about 8 feet and 14 feet and 22 feet. Okay. I think one of the things I need to do is turn this sideways. Because I think it says these should be in every other classroom. This is probably how they're stored, down on the bottom of the tray or something like that. So I always just thought this looks better, but maybe I'll turn them. Just make sure I don't turn it to the right. That would be bad. Yeah, we're nodding our heads. Yeah. We are awake, right? Yeah, this came up in a discussion too. I was telling how I drive bus, and like the elementary students, they're so excited to go to school, and then one of the professors, he just mimicked, and then you have the high. And I said, and I got the high schools, so I see walk in, and he, ugh. Isn't that about right? And if it's one day, what's it the next day? Same thing. Blah. Okay. All right. So what I want you to say is cis or trans. Okay. So then, if that's how we're going to view that, which is fine. Okay. How could we know that's a cis compound because that's what you picked, and from prior knowledge, you correctly identified that alkene as a cis compound, but it doesn't explain why you knew that. Right. What's the same way though? Just so everybody else knows. The carbons are the hydrogens. The hydrogens. So when we see these derivatives, we see these pointing in the same direction. Okay? Now, should something like this happen, okay, where if we have that, okay, then what would you guess happens? Is that a cis or trans compound now? It's when you have two derivatives. But when you have three, now you don't have those hydrogens in the same direction because it's not a hydrogen on there anymore. It's a methyl group. So that's kind of a fine distinction in that, yeah, it's no longer cis or trans. And we'll turn the page and name that in just a moment. But when you look at page 314, then that gives you somewhat of an idea of how to name that. So look at the bottom, or whatever those are three-sided figures. How would you name this compound then with what you see on 314? Okay. See, I always get mixed up too. Is it 1,3 or is it cis that comes first? And okay, so it's the cis that comes first. Okay, cis dash dimethyl. Okay. So then, how would we see, I'm trying to combine two words, and like change and trans, so it comes out trange, okay? So how do you change this to a trans compound now? Yeah, you could either put this one down or you could put that one down. Now, you don't have to write it like this. This is just what makes sense to me. And so the hydrogens would be on that side. If you decide to write it like this, that's not wrong. It's just, I just attach the carbon, I put the hydrogens on the other side. Okay, so if we wanted trans 1, 3, and see here we got a little more space maybe, and that's how we would change that to a trans compound. Okay? All right. Well, let's go ahead and leave that up there. And then if we turn the page then to page 316, and what you see there as some of the examples up there on top, we see a cyclohexane molecule, okay? And then they are denoting where all those methyl groups are. 1, 1, 2, 2, tetramethyl cyclohexane, okay? Then with what we see here we just drew this. That I forgot that those are on that page. So look, we already did that correct. All right. And then we really don't get into the next set of ring structures. We do, but notice you have 3 different types of derivatives on those ring structures, where it says 1 bromo, 2 chloro, 1, 2 dimethyl cyclopropane. Okay, and there again, you're just assigning the lowest numbers that are also in alphabetical order. Okay. Any questions? And you might see, I'm sitting in some of my classes and I'm thinking, I'm so confused, but I have no idea what to ask even. All right. So what we want to do is go ahead and flip forward to page 321. Okay. And really, one of the things that we had talked about the first couple of days is a lot of the way maybe chemical reactions are taught is, yes, you still may have your double replacement reactions, but then you may have reduction synthesis. You may have oxidation synthesis or oxidation single replacement. Okay, so that is kind of related to what we see here, because if you see where it says combustion, about 2/3 of the way down, when you look at that reaction, how would you have known that that is a combustion reaction other than us just saying that it's a combustion reaction? Right, because you have the same byproducts and you have a hydrocarbon that's combining with oxygen. So then when you look at the black bold letter about an inch further down or inch and a half, okay, combustion is an example of an oxidation reaction. Okay, so don't be surprised if that's what happens when you take this in college, because that's news to me. That just happened over the summer, taking some of these courses. So I would think older cis maybe thinking, okay, I did not learn this in high school. Same for yourself, and maybe same for yourselves. I don't know if they do that in a freshman college chemistry class or not. Maybe they just still stick to, and I don't know if older brother or sister took chemistry in college. And no, okay. So then, and you wouldn't even know unless they told you that. And I don't know if they come home and you have specific conversations. Okay, so how's college going? What do you think I need to work on? Do you ever have conversations like that at all or no? Okay. Is it enlightening or, oh boy? It's kind of, it could very well depend. I would agree. Okay. So one of the things, we're just going to read through this. It's on page 324. I'm trying to think of where it is. Probably just close up there to the top where it says halogenation, and in parentheses, halogen substitution. So without even going any further, when you're talking about halogens, who would that be? That's 1. Bromine. 2 more. Fluorine. My eye's on you. I didn't know if that was a good clue or not. Okay. So, halogenation. Molecular halogens, fluorine, chlorine, bromine, react with, and I got iodine up there. But for our purposes, we'll throw that in there. React with alkanes and cycloalkanes, but only in the presence of heat or UV light. The reaction called halogenation substitutes a halogen atom, your fluorine, chlorine, or bromine, for a hydrogen atom in the alkane or cycloalkane to form an alkyl halide.
Mr. McKinney, buddy,
Who's that guy? Okay, sorry about the interruption. That might throw us off just a little bit. Okay, so let's try to get this wrapped up. Okay, hydrogen atom in the alkane or cycloalkane, an alkyl halide. So what that means is an alkyl derivative, there are 8 of them. What do you suppose? Just start naming some. You know what they are, you just don't know you know it.
Carbon.
Not carbon. That's 1. 2. Propyl. Okay, and then your butyl groups. That's an alkyl derivative. So then if you're talking about an alkyl halide, well then that's going to be what would resemble a derivative with a halogen attached. That's what an alkyl halide means. The term alkyl halide encompasses any organic compound containing 1 or more halogen atoms. A number of halogen-containing products are important for commerce and everyday life. Okay, so what has to happen is, notice you have methane plus Cl2, and then for the reaction to proceed, you have to have what? One of 2 things. Right. Okay. And if you don't have that, there's no reaction to it. Cycloalkanes and alkanes in general, it's what's called pi bonds that's in between those. They are just too stable to react unless there's a catalyst to push it along. And that's why before we got to these, I was going to say, yes, these are written correctly. I was just going to see if anyone had noticed if there's something that might stand out in your mind with these 2 organic reactions. And we did just read that. And you did just answer that too. For the second one. So then when you approach this one proceeds because it has either the UV, the ultraviolet light, or the heat, where this one then does not. And you'll see this in examples in here where they're going to have questions that would illustrate these for their reactions, and some will have nothing underneath. And yeah, I understand maybe that looks like it's a trick, but it's just a part of understanding how organic chemistry works. Okay, so notice that within organic chemistry, you're concerned with balancing the reaction. Okay, so if you have 2 chlorine atoms and it goes through a substitution, we'll just look at this for example. We'll change this. As it is right now, that's no reaction, but we'll go ahead and put even just UV light. I just abbreviate that, or just HT for heat. Now we know this reaction can proceed. So if C2H5 is an alkyl derivative, which it is, what would the alkyl halide be then? So this is going to proceed now. How many carbons are over here? You're still going to have these 2. So what would you guess is on this? Well, we can always put these on here too. So what might be on this left carbon? Okay, and what we see happening then, so we'll put a chlorine atom there, and then we still have all these hydrogens left over. When we would discuss this within organic chemistry, you would probably say we have to have this, oops, well, I can make that work. You have to have that balance this out because there was a hydrogen here, but now it's a chlorine. And how many chlorines did you have to start with? Because it's diatomic. So you have these 2 chlorines, this hydrogen gets replaced by that chlorine, and then that hydrogen then it's still there, it's grabbing the other chlorine that was left on this side. Okay, so this is what the next sentence says. And If you feel like you want to put this, I don't know what's going to be expected of you next year, okay? Because I can picture different universities, different professors having their own way that they want to look at this. This is what we mean. The next sentence, organic chemists often write chemical reactions in an abbreviated form such as, it didn't make sense to me, so it doesn't mean that you can't make sense of that. It just means that this helps me to explain this to you. Because if we look at this, how the author chooses to write it, you wouldn't have this plus sign here. You'd still have this arrow. It would be here, and you still have your UV light. But what do you think might go on top of that according to what you see on 316 or whatever that is? Yes, your Cl2. Now, this might be how you would see that proceed. But I personally don't like that, and it doesn't mean that you have to do it this way. To me, this just makes more sense. Just go ahead and continue to do this, and then I'll just put UV there. And then, again, it just says they're not concerned with writing chemical reactions and balancing them. They're just more concerned about what your product is. Now, sometimes we say this is in excess. What can happen is, notice you still have more chlorine that's still going to start to attach to other parts of the carbon chain. That's probably more common when you have 3 or more. When you just have 2, we're not too concerned about that right now. This would probably be our only product right here. And if you put plus HCl, that's fine. If you don't, that's fine too. Because we'll see substitution reactions also when we get to the aromatic structures. And then there it's probably a little more common to do this. But since we got interrupted, we just have a few minutes left. So, shoot, I do have that on the schedule, assigned worksheet 3. Notice when it says 9/4, when is that? Wednesday. That's Wednesday, because we don't come back until Tuesday. But we may change that to 9/5, which would be a week from today. So since I handed those out yesterday, I'm going to hand it out today, and you'll have Tuesday and Wednesday to work on that. So so keep in mind, let's see here. I have your vocab terms. I got to print those out and hand them to you. So next week, we'll work on the 3rd paper, and then probably have a vocabulary evaluation and maybe your first problem quiz a week from tomorrow. That would be, I think, just naming organic compounds. So I think we're getting this done just in time because we're running low on power. That's why it's blinking. So anything else to add about today or next week? You have some papers. I'll collect them. Make sure your names are on them. We'll catch up to you next time.